Hello! In this video, we're going to take a bit of a meandering walk through some different functional programming principles, looking at how arrow functions can really clean up our code and how we can use functions to keep values a little more protected. So let's say that you're contributing to a code base and you are going to add a variable called myList, and it's going to have 1, 2, 3, 4 as the values. And then you're going to create a function called add1. It's going to accept an array, and it will return whatever array is passed in. It'll map over that array with a function that, as you might expect, is going to add 1. So we'll console log my list. We'll console log add 1 with my list passed in. And so I would hope that nothing here is going to be a huge surprise. You'll get 1, 2, 3, 4 and 2, 3, 4, 5. Okay, now let's say that for some reason you assumed that people might do some devious things. So you think maybe someone will take my list and they might reassign it to instead be 3, 4, 292. Well, obviously at that point, you're going to get totally different values than you wanted. You wanted 2, 3, 4, 5 as the result, and instead you're getting 2, 4, 293. Well, maybe you think, all right, well, I can use something from ES 2015 and prevent those sorts of reassignments by using Const. So that will just throw an error because Const prevents you from reassigning a variable to a new value. But a common misconception is thinking that it makes this value immutable. It simply does not. We can very easily, we're some devious programmer, pass in another value to adjust the original value. This is not being reassigned. That assignment is still existent. It still exists just as it did before. You'll notice that there is no equal sign, which is the assignment symbol in JavaScript. Yet I'm going to, without problems, push a new value onto that original array, giving us a different value that returns. And that's not what we want. So let's say instead we want to wrap that in a function, because we know that if we wrap it in a function, then we can just call that function and it'll give us that value. And in a sense, it's protected because it's inside of a separate scope. So now, if we just turn these guys down here into functions, or function calls, I should say, then we're going to essentially be in the exact same situation that we were in before, except now we have a bit more protection of this value because it's wrapped in a function. So we get 2, 3, 4, or 1, 2, 3, 4, and 2, 3, 4, 5. But if we had a bunch of variables to assign, this could get pretty clunky. And this is where arrow functions can clean up our code. So we'll get rid of the function, name at the beginning. We'll add in an arrow. And if you remove the curly braces, then that becomes an implicit return. So you are saying the exact same thing here. Function implicitly returning this value. And it looks very similar to a normal variable assignment. All we've added are a couple parentheses and an arrow. But if we run this code, then we get the exact same thing that we had before. So that's pretty neat, and it's very clean compared to the way it was before. I think that's very easy to read. I think if you see these and you know that it means an arrow function, hence the arrow, then it's a very quick, easy thing to spot at a glance. I don't think that's overly confusing. And one thing that bugs me down here is all this extra nonsense that we have going on within our map function. All we're doing is taking a number and adding 1 to it. It does not need to be this complicated. So let's clean all that up. We'll remove that. And all we're accepting is x. Oops. X. We are going to implicitly return that guy, like so. X is the parameter. Remember that. Implicitly return it, and we're going to, or I should say, implicitly return x plus 1. So we save that, we run it, and we get the exact same thing that we had before. And so this is a very contrived, basic example, but it shows you how arrow functions, when they are used in simple situations, can make things a lot easier to read. I think that putting this all on one line makes it pretty clear. You're taking x and you're returning x plus 1. There's no craziness going on there. And if you're new to arrow functions, just so that you are aware, if you wrap it in curly braces, the implicit return goes away, and you can perform whatever other logic you need inside of here. So if we wanted to, say, assign x equals 22, like so, and then return x plus 1, we run that. Now we're going to get 23, 23, 23, 23, because we just chose to reassign x. So using an arrow function doesn't mean that you automatically have to do an implicit return. You can do logic. You can put it all in one line like I did with a semicolon, or you can split it out over multiple lines like a normal function, like that. So it's totally up to you and how you want to do it. I think that the original way I had it makes the most sense for this situation, unless for some reason x absolutely, positively always needs to be 22. Oh, and the whole point of this was so that at the end, if you were to call my list, then my list hasn't actually changed. If I go down here, 1, 2, 3, 4. Oh, I totally broke something. Oh, I didn't return anything. That's why. Remove that. There we go. So you get 1, 2, 3, 4. You get a new value because you've added 1, but my list has stayed exactly the same. It's still 1, 2, 3, 4. So quick introduction to arrow functions and how you can use functions to return values in ways that protect those values a little bit from maybe some malicious coders out there. Hope you learned something. Hope you found it interesting. If you did, let me know. If you want to learn something else and you actually watch these videos, you're one of the few, then let me know what I should do next. I'm thinking map, because map is super cool. See you in the next one, guys. Bye.